Hello everyone, this is Shakil Ahmed. In this tutorial, we will discuss more about the shape values that is a part of explainable machine learning models. We previously we discussed about the simple linear regression, multiple linear regression, and the generalized additive models, and just try to know how we can interpret the shape values and what are the shape values. So in this tutorial, I will show how we can do this for a random forest model that is the most widely used machine learning model with its extension like XGBoost, adaptive boosting, and other extensions. So we will try to keep simple and discuss how we can apply on a data set that is from Framingham heart study consisting the chronic heart disease outcome and a number of variables including clinical and demographic variables. You can see I have already uploaded the data and you can see first 5 observations. So import pandas that is needed to import data from CSV, and then PD read and underscore CSV to import the CSV. Uh, Google Colab, you need to upload data here using this option, and then you can we are just copying the 1,000 observations to make it computationally to make computations simple. So you can get the results, the data from this website, Kaggle. You can just type Framingham Heart Study data set and click Kaggle. So I have already pre-processed data by imputing the values, missing values, as we have a few number of missing values in education and in cigarette per day and in glucose level as well. So you need to definitely think about handling missing values in different approaches, and whether you are going to ignore these values or you are going to impute these values. For keeping it short, I just imputed the continuous values with mean and the categorical ones with mode. You need to first categorize the columns, quantitative columns and qualitative columns based on the variable types in float and integer that are quantitative, and the object that is uh, discrete qualitative data. So now we use imputation command for column in this set. We use if is there any null, we replace that value with a mean of the remaining values. Basically, we are just finding the mean of the remaining values. So you can use this bunch of code to replace mean of the complete cases to the missing values in the specific columns. So this will done for all columns if there is any missing values. Otherwise, it will definitely skip the column. And the same thing we can do for the qualitative columns, and then replace the missing values with mode, and then we can check how many missing values we have. Now we can see there is no missing value in any of the variable. So for applying a random forest, and we want to see different predictors we have, for example, 10-year chronic heart disease is our outcome variable, and we just saw want to see the effect or impact of all these variables on 10-year chronic heart disease. So we want to include all these once at a time, once in the model. And definitely random forest does it by selecting the variables in different permutations and to obtain the shape values. Basically, we can uh, while running a tree, we need to sort different variables. For example, we start with the male and then age and then education, or we can start with age and then male and then education. So these are called the permutations. We have different possible ways of including the variables, entering the variables in the model. So we will, that is called permutation. We will conduct this for all possible scenarios, and then we get contribution of each variable in the model. So for that we need the shape package, and for splitting the data we need trend test split and random forest classifier for building random forest, and accuracy score to check the accuracy score, the prediction, and then classification report that tells the classification summary. For example, the positive, false positive rate, uh, true negative rate, and other things, F1 score, recall, precision. So we are importing these packages, and then we have X that includes all the columns excluding the 10-year chronic heart disease, and Y only 10-year chronic heart disease. So this is our outcome variable, and this is our uh, set of predictors, and we can just separate the data into uh, 80-20 ratio. We are keeping 20% as the test set, and then we run a random forest. We construct a random forest with n estimates is equal to 100. That is the number of trees. You can increase number of trees, and a random forest fit. uh, this command is used to fit a random forest and then get y prediction, random forest prediction on test set. And then we can just find the classification report, and I have predicted them. You can see the precision is 90% for this class and 5% for this class, and overall the average is 0.51. The precision is not that much good, and the recall is 57%, but the weighted average, if we see, that is 0.95. So that is somehow good. And uh, to compute shape value, basically we need to create an explainer object, that is the random forest in our case. So we find the explainer shape tree dot explainer. So basically we have already trained a model on our training data that is called a random forest, and now we are predicting on that trained model for the new data set. So we have X test, and here you can see this is the random forest we have trained, and we are now uh, obtaining the shape values based on the test set X test. Although we can find the shape values for all the data, overall the data set, instead of only X test. So just run this to take a little time, as the data set is not that much large. If data set is large, then it will take a lot of time. Basically it permutes, and then for every possible combination it finds the shape value. Now we can make a waterfall plot. For waterfall plot we just apply the explainer on X test, and uh, shape value, we store the shape values by instance. Instance means for each observation, and then we can plot them using the matplot library plot. This is basically finding the shape value for a single instance index is 0. So let's see what happened. You can see these are the contribution of different variables. This is the expected value of y. We can say that is 0.163 when no variable was included. Basically, this is just predicted value on the trend data. But when we include uh, 6 other features that have very less impact on the predictions, so this is just decreasing by this amount, not that much. These are increasing basically, uh, but the value is 0, and this increased the prediction by 0.01, and this increased the prediction by 0.01, and heart rate decreased the prediction by this. So these are the uh, prediction for individual level, uh, when for different features. If we include the contribution of different features for predicting the specific individual outcome of the individual. So you can just see. So this is basically the prediction of getting the heart disease, that is the mean, you can say. And these are the change in predicted mean when including these variables in the model. Then we can make the bar plot using the mean shape values. We can get the shape values by averaging them through all instances. So how we can average them? Just mean absolute. You can import the numpy for to obtain the mean and explainer x values. Here we are using the shape value for all data set, not specific to the test set, and then finding the mean. So you can see, and then use the you can just flatten the mean absolute shape values in array. You can just make a an array like vector or list, and then you can create the column for the features. Basically, you are finding the mean values in terms of a vector, and then another vector or another list with feature names, and then you can combine these two. For example, feature 1 and the value of that feature, feature 2 and the value of that feature. So you are just merging them using the zip function, and then uh, just find the list that is called feature importance. Basically, these are the mean shape values. And then feature importance dot sort, we are just sorting them based on the lambda value, basically the mean shape value. The largest, the variable with the largest shape value will be on the top, and the smallest contribution will be on the bottom. Uh, and then we can just separate these two columns again, the feature names and the feature values, the shape values, basically mean shape values. And then we can make a plot using these two. On x-axis we have feature uh, names and sorted mean values on y-axis, and then this is bar horizontal, so it will be horizontal bar. If it just if you plot just bar, then it will be a vertical bar. So that's not a problem, and you are giving the title and the overall title for the plot for the x-axis, and then see the plot. So here you can see the absolute mean value. Basically, these are the absolute values, so all are on the right side. starting from 0. For example, BMI has very small contribution and heart rate also has very small contribution, and the current smoker has the largest impact on the shape value in predicting the chronic heart disease. So the value variables will have three attributes: one value and the base value and data. So base value is basically the expected value of the target or the average target value of all the trend data. The predictions we get across the trend data. So that is called the base prediction. And then we will get the target prediction, and the difference is basically the shape value. If the difference is this difference is higher, then we say that this variable has a higher impact and vice versa. So we need these three things uh, in getting the shape value related plots. Again, we can see the shape values for all across all individual values and uh, all the features. Basically, for example, for male we have these shape values, so you can get just another data set with the shape values. So we have just extracted the shape values here. Here we are not fixing anything. Basically, above we had fixed the value as specific index. That was the first index. You can say here this one, the first row. But here we are just keeping it empty. It means we are selecting all the rows. And then shape data frame, you can just create it a data frame with rows, shape value classes, and columns as X columns, and then display the data frame. And if you want to see the distribution and other things, you can just click here. It will provide different type of charts for you, histogram and the distribution as well. You can, if you want to explore more. And the other plot is the Beeswarm plot. That Beeswarm plot is Beeswarm plot. It's Beeswarm plot, and you can see shape values class 1, and then you can just summarize this using the Beeswarm plot. So Beeswarm plot just display all the shape values for all individuals and all features. So for example, if we see for age, we see the distribution of shape values like this. Red means the shape value is on positive side, and blue means the shape value is the impact is on negative side, and these are the distributions. Most the values are dense here near on 0 side, but these values are small, but the positive impacts are even not dense, but we have larger impacts. For example, one instance is giving 0.25 shape value. So these are the impacts we can see for the individual data and for different features. Then all the little dots on the plot represents a single observation, as I discussed, and the horizontal axis represent the shape values, and the colors as we already discussed. So another way to just see their distribution, and that is called, you can say, the violin plot. You can just display the violin plot. That is just a smooth plot for this, and you can see the distribution and mode, maximum values and overall distribution. This is just like a box plot in case of continuous variable. So it shows the outliers and middle value and quantiles and the modes as well. For example, this data has two modes, one is densed here and one is densed here. So you can just display this to get a more clear picture of the shape values. So that's all about the shape values and their interpretation. For more videos, you can subscribe my channel and follow. And if you have any question, you can always write in comment box. If there is any error in codes or in interpretation, you can always write. Thank you so much.